Hi, welcome to another video. Today we'll be solving the question of inserting a node in a sorted circular linked list. So here in this example, we are given a circular linked list. So in this circular linked list, the head is pointing at node 1 and we have to insert a value 4 in this linked list. So here for this linked list, the final output would look something like this: 1, 3, 4 and 5. So the final linked list that should also be sorted. So by sorted, I mean it's in non-decreasing order. So this linked list can have duplicates. So this node 4 is going to come in between these nodes 3 and 5. So we have to find a position where we can insert a value. So to think about this problem, first let's see an example of a singly linked list which is not circular. So let me redraw this again. 3 and node 5. And here my head is going to be at node 1. So when the linked list is not circular, so we know that it is guaranteed that we are going to find a null node in our linked list, and if it is circular then we can never reach a null node. So for this case, when the linked list is not circular, we can easily insert a particular value in the linked list. It's really simple. We just need to iterate over the linked list and we need to keep track of current and next pointers, and if the value falls in between current.val and next.val or it is equal, then we can insert it between these two nodes. And for the edge cases, it could be that our value can come before the head or it can come after the final node, like after 5. So that would be really straightforward and we can solve that. Things can get tricky when the given linked list is a circular linked list, because the head of the linked list can be any node. So when we talk about the head of a linked list, what it means is from the head we can reach any other node of the linked list, and in a circular linked list the head can point to any node. So in this example, the head can point to node 1, it can point to node 3, it can also point to node 5, because from any of the node in a circular linked list we can reach all the other nodes. So that is why head can be any node. To understand this problem, one thing is clear, that whenever we want to insert a node in a linked list, it is going to come in between two nodes. So we are going to need two pointers, and let me call them as current and next. So a simple case where we can insert a node in between these two nodes, it would be when value is less than equal to next.val and value is greater than equal to current.val. And also we are going to check for this condition when we are iterating over the linked list. So for our given head, we are going to start from our given head. So we are going to start from our, let's say node 1 is our head. So I'll assign my current as head and my next would be my current.next, and we will keep iterating as long as current comes back to its original position. So as long as current is not equal to head, we will keep iterating. So initially we have already set current equal to head. So if we check while current is not equal to head, so that would be false, right? So for that case, we can either use a do while loop, so that we do the processing first and then we move our current pointer, or if we want to use a simple while loop, what we can do is we can set our current as null, and then inside the while loop we can check, the first condition we can check is if current is equal to null, then we set current equal to head, and then we can simply use our while loop and keep iterating over the linked list. This check would work well for simple test cases. So let me call this as case 1. So this would work fine for simple cases such as, let's say we have 1, 1, 2 and 4, and we have to insert a value 3, or we have something like 1, 1, 2 and 2, and we have to insert a value 2, let's say. So this 2 can come between these two nodes and we can insert it here, because we are checking the equality as well here. So what is going to happen if the inserted value is going to be a new maximum or new minimum in our circular linked list? Or what would happen if my linked list contains all same elements, such as, let's say, I have my circular linked list which only has nodes with values as 1. So these are circular. So let me also create the final link here. So what would happen for these cases? Let's say we have this test case where there are 2 nodes in our circular linked list, and both of these nodes have value as 1, and we have to insert a value 2. So here, for this case, let me first draw a current pointer and a next pointer. For this case specifically, we might get distracted into thinking that we might need to check if our value is greater than current.val and it is also greater than next.val. But we should not deviate from our approach of using 2 pointers, and we should try to fit this value in between 2 pointers, current and next. So let me draw a bigger example to understand this easier. So let's say I have 5 nodes, each node has value 1, and I have to insert a value 2 in this circular linked list. So think about what could be the possible position for this value 2. So this value 2 can come in between any node. So think about it. So let's say I put this value 2 between these 2 nodes here. So this would become like this: 1, 2, 1, and then 3 nodes as 1, 1, and 1. So the thing to ask ourselves is, will this linked list remain sorted after inserting a particular value? So for this linked list, the answer is yes. This linked list would be sorted, because if we think from this node, so it would be like 1, 1, 1, 1, 1, and then 2. So the node 2 is the biggest value and node 1 is the smallest value, because the head can be any node in our circular linked list. So that is why this is one possible configuration. And what if my node 2 comes here? So let's draw that. So 1, 1, 2, 1, 1, and 1. So this is also a possible configuration. So for this case, we can insert our value in between any possible state of current and next pointers. So let's say my current is here and my next is here. And what if my current is here and next is here? Then also I can insert my node 2. And what if my current is here and my next is here? I can insert my node 2 in between current and next. So here we don't really need to find current and next. We can simply insert our node in between any 2 current and next. As long as next is equal to current.next, we can insert our value there. Now let's have a look at another test case where we need to insert a value 6 in this sorted circular linked list. So here, as you can see, this value 6, when we insert it, this is going to be the new maximum for this sorted circular linked list. So here the head is pointing to this node 1, and we have to find a place to insert this node 6. So what we can do is we can simply start with initializing current and next. And so we check, does 6 fit here? The answer is no. Does 6 fit here? The answer is no. And now we come to node 5. So our current would be at node 5 and next would be at node 1. So can we insert this value 6 here? So the answer is yes. So for this test case, we have to do another check where we are going to check if current.val is strictly greater than next.val. So before reaching node 5, so here as you can see, the next.val is greater than or equal to current.val, and only when we reach node 5, the situation flips and suddenly current is greater than next. So this node 5 is basically the largest value in our sorted circular linked list with respect to this node 1. So we can also call this node as a pivot node. So let me call this pivot. So think of pivot as the biggest element in our sorted circular linked list. So here for this case, the current.val is greater than next.val. And when this happens, so what could happen is we can insert value 6 here. So what if we need to insert a value 0 in our sorted circular linked list? So this value 0 can also come in between current and next, because if I insert the value 0 between 5 and 1, then what's going to happen is my linked list would look something like this, we'll have 3, 5, and let's say 0 here. And now with respect to 0, my linked list is sorted, and if I insert 6 here, then with respect to my node 1, my linked list is sorted again. So along with this check, what we can do is we can add another check where our value can be greater than equal to current.val, or it can be less than equal to next.val. So if this condition satisfies, then we have found a position where we can insert our given value. So this would be our case 2 for this problem. And if neither case 1 or case 2 satisfies, whatever the state our current and next pointers are in, then we can simply put that value in between current and next, and that would be the case when our linked list would have all duplicates, and then we would be done. And one more edge case that we could have is when the given head is null. For that case, let's say we have to insert, let's say, value 4, then we can simply create a new node with value 4 and just point to itself and just return that node. And what if we have only one node in our linked list? So this would be an example when linked list has all duplicates. Then for that case, our current would be here, our next would be here, and this would not satisfy our case 1 or case 2. And we could simply add our value between current and next. Let's say if we want to add value 2 or -1 or whatever. So now let's have a look at the code implementation and run some test cases to understand this better. Here we have to implement this insert function where we are given the head of our sorted circular linked list and insert val that we need to insert in our linked list. So let's first start by writing our edge case where head can be null. So for this case, we can create a new node with the given insert val, and we need to point the next pointer to itself, and at the end we can simply return new node and we would be done. And as discussed from algorithm walkthrough, we are going to need a current pointer and a next pointer. So I initialized current as head, and we can use a do while loop, and in our while check we need to check current is not equal to head, and inside this I can create our next pointer where node next equal to current dot next. And here I can have my first case where I can check if current dot val is less than insert val, less than equal to insert val, and insert val is less than equal to next dot val. So if this case satisfies, then we have found a position for our value to insert. So we have found a configuration of current and next pointers, and we can simply insert our value in between current and next pointers. So here we can break out of the loop, and after breaking out of the loop, we can write our logic of inserting this value between current and next. For that, we can create a new node equal to new node insert val, and new node dot next is going to be equal to current dot next, and current dot next is going to point to new node. So we do the insertion after we are done with our while loop. And similarly, I can write my case 2 where we discussed that current dot val can be greater than next dot val, and inside this we're going to have current dot val is less than equal to insert val, or insert val can be less than equal to next dot val. And then again we have found a position to insert our given value, and this is for the case when the inserted value can be minimum or maximum. And for the test case when our linked list has all duplicate elements, then we are going to iterate over the linked list and neither of the cases will satisfy, and we'll come out of the while loop and we simply insert our node in between current and next, because for that case any configuration of current and next would work and we would be done. And also inside this loop we are going to move our current equal to current.next, and yeah, that looks good. And I have created some test cases, so let's try to run those test cases and see if everything is okay. So let's try to run it, and from the logs you can see that all the test cases have passed. So I hope this made sense and you got a better understanding of solving this question. So if you have any doubts, let me know in the comment section, and thank you so much for watching, and I'll see you in the next video.